All right. So in this video, I'm going to, you know, share a glimpse of reactive programming or stream programming. This is the type of programming that I'm using for my social media monitor that I'm working on. Um, the library that I'm using is part of an umbrella project called ReactiveX. And the since I'm using the JavaScript language, the library I'm using is RxJS. This one. So, but you have you know libraries in other languages having the same interfaces here. You have it in Java, .NET, Scala, Clojure, and Swift, and this is the complete list. You have enough of them. What is stream programming? I don't know how to explain that. um, but I like to when I'm dealing with data from multiple sources and I want to control them, the speed, the coordination between them. I think it's easier. This stream paradigm is easier to deal with, to work with, compared to maybe the multi-threaded approach. I don't know. So, but I like to see it that way. It's like you know, controlling the flows through rivers and all the branches. Because rivers, it can split into smaller rivers branching out, and then at some point it merge into a big river and things like that. So first, let's have a look at the social media manager that I'm working on. It will give you a background of what the experiment is about, what I'm trying to achieve with this code. And then by looking at the code and through, you know, some quick explanation, I hope you can start getting to know this stream programming with RxJS. Uh, let's see, reset stream. Whoa, wait a second. Okay, so I'm monitoring the conversation on Twitter. I have a crawler. That you know that issues requests to the Twitter API using some search criteria, whether the name of a person, the name of the hashtag word, some keywords and things like that. Those requests um, is represented by this request of type tweets.json. Uh, Twitter API can also accept other types of requests, such as this one, show JSON. This is to get uh, like a more detailed version of the tweet. So with this tweets JSON, you get a list of tweets that match certain criteria that you specify in your request. But it will only contain the short version of those tweets. If you want to expand that, you have to issue this request for each one of those tweets, right? Also, this request retweets.json. What is this for? So a tweet can be a reply or a retweet of another tweet, right? So when you look into the tweet JSON, you can see a field that says, this tweet is a reply or a retweet of the tweet, another tweet of with this ID. So if you want to know about that original tweet, you have to issue this request to the Twitter API. And this one, the last one, It's, I think it's clear from the name. It is used to obtain information about the person who posts the tweet. So, so I have four streams here, four different streams, and I want to apply like some timing strategy maybe with some priorities. Obviously, I prioritize this request because I want to get as many tweets as possible in a short time. So this has higher priority. By higher priority, I mean I issue requests of this types more frequently. So let's say every half second. And then the second one, the second priority is this one. So show JSON and so on. Eh, So yeah, you got these streams ordered in decreasing order of priority. And then the next idea is the speed of these streams should adapt to the speed of another stream of higher priority. So this stream can dry out. Let's say we have reached the end of, there's no more results that can be returned by the Twitter API for your searches for whatever reason. So you get less and less tweets. You get less and less response. As the time goes by. When that happens, I want to speed up issuing these requests, and the same thing happened here. At some point, it will dry out. There's no more requests to be issued. Maybe your queue is empty, and then okay, you can speed up this stream and so forth. This is the code that I wrote like more than 1 year ago, and then these days I'm evaluating my codes and I see some weaknesses here. For example, there's no way of going back to the normal pace. So once it dries out, yeah, it would this show JSON stream will step up to the speed of Twitch JSON, but it will stuck there forever. And why does it matter? Because it's like river. You got your cycle. One after a certain time you dry out, but then after a few moments later, water starts flowing again, and then so yeah, at that point you want to scale back. You want to step down this stream. You want to return it back to its normal pace. Currently, this code cannot do that at this moment. So that's why I'm doing this experiment using playing around with the API of RxJS to achieve a better behavior for my crawler. So to simulate that, I'm working with three streams here. The main stream, and then I split that main stream into tweet stream and retweet stream. And then I have a queue. This is like I simulate the initial requests, list of requests that will be pushed down the river. So it will be pushed. The entrance will be the mainstream will be the entrance of these requests, and then at some point it will be split into two smaller branches. Each branch only contains specific types of request. So I have the queue here, like a basic data structure with the basic interfaces for a queue. You got push and pull, and then for the mainstream I have this class, a request emitter. Maybe just to make it clear, I should just name it mainstream. But anyway, uh, this request emitter is something that we call a a cold observable. A cold observable. What is cold observable? There's an article that explains that concept. So the cold observable is a so observable or stream that starts that is activated or starts flowing whenever you attach a subscriber to it. So it's like let's imagine like a frozen river. Until somebody subscribe to it, until somebody thaw the river, there's no water is not going to flow, right? So that's what we call cold observable. uh, okay, so what this request emitter does is it pulls from the queue one by one and push its request. It pulls from the queue down the river. But to avoid doing it in a burst, I want to control the pace. I want this request emitter to pull from the queue every 1 second. I have this thing, which is another stream. It's like a heartbeat. Uh, on in this code, I how do you call it? Analogy. Visualize it as like a tap, as like a water tap. So you have a tap with 1 second interval. It's like it's like opening and closing the gate of the river every 1 second, right? So this is what I do. Subscribe, and then every 1 second this block will be executed, and within this block I pull from the queue and push it down the river. And here in these two lines I simulate the crawling, the expansion of the crawling, by appending new request, just by adding dot here to the end of the queue. All right. So we got the main branch, and at some point I split that branch using this code. This is like a custom code that I wrote. Split stream, blah blah blah. And each of those smaller river also has its gate. For example, the Twitch stream has a gate that opens every 1.5 seconds. There's a constant defined. Oh yeah, 1.5 seconds. And the retweets stream has a gate that opens every 3 seconds. Then I have this orchestrator. This is like the meat of the code, the scheduling mechanism, the coordination. Here in the taps orchestrator, I simulate this scenario. So after 20 seconds of running the program, the tweet stream will dry out, or maybe it's more accurate to say the tweet stream will the gate of tweet stream will open less frequently. Instead of every 1.5 seconds, it will open every 27 seconds. And then after a few moments later, after 55 seconds, the tweet stream will go back to its normal pace. Again, it will emit it will push through tweets request every 1.5 seconds. So what I'm trying to achieve with this block of code is I want to detect this dry the I want to detect when when the tweet stream has dried out. It's simply by checking, the speed at which uh, new item is flowing through the tweet stream, right? So if it's normally, if tweet stream normally comes every 1 second and a half, and then all of a sudden it doesn't even come after you wait 3 seconds, then you can say, oh yeah, it has dried out. When it's dried out, I change the interval of the retweet step of the so I make the gate of the retweet stream open more frequently. Now instead of 3 seconds, it will open every 1 second and a half. Yeah, so basically it takes the pace of the tweet stream. But when this thing happens, when the tweet stream goes back to its normal pace, the retweet stream will have to go back to its normal pace as well. So it will go back to the 3 seconds periodic openings. So that's simple. That's basically what this orchestrator does, manipulating the the speed at which the gates open. So what else? Yeah, so that's all the code. Was how am I going to test it? I'm in for this video. Let's just do it in a conventional way by looking at the output. But if you need to write a unit test for your reactive code, you can use something that is called marble testing. So it's like a visual testing. You got the timing here. You specify it using dash and things, and then you apply operator in these two streams, and then you compare your expectation with the output. Or if you want to understand, get familiarized with the operators that so yeah, I just mentioned the word operators. Maybe I should introduce what operator is. Observable. Where's observable? There. So the name of the class, so I always use the word stream when actually in the API it's called observable. So these are the list of operators of a stream. Oh, sorry, this one. Yeah, you have a long list of operators. So, and this documentation actually explains, even using this thing called marble diagrams. So, but if you want to, you're curious, you want to play around with those marbles, you get this tool called RX Marbles. It's online. So for example, you want to understand what this zip operator is about. So you look for this operator, zip, and you got these two inputs, and then you apply these zip operators, and you get this the output, this stream output. So this zip is basically pair together items from the two input stream. So you got 1A, 2B, 3C, 4D. So it can be used as a pacing mechanism. So this one is like the pacer, and this is like the source stream. So this way you can control that, okay, at the end of the receiver, this item will be received at this specific point. So for example, let's suppose the input stream is so fast, but the processor, the receiver is slow. You want to apply zip here with the spacer, right? So you see, instead of receiving a burst of 1 2 3 4 5 1 2 3 4 5, you'll get, you know, you'll get it in a slower pace. So this is a very useful tool for understanding the reactive programming. So let's just run our code now. Remember, let's see, where's the code? I put this console log. So if for each a request that arrives at the end at the receiver, I simply print out this message with the request, so I can see which request has reached the end of the stream and the date. But don't count too much on the date, on the exact date. First, because this is not a hard real-time library. And second is because Node.js is not multi-threaded. It's an event loop based, so things can get delayed by, let's say, 1 second or even more, depends on how much thing you do in between. But how do we confirm if our code, if the behavior of the stream is correct? Well, just by like estimates or by visual inspections, which we'll see right now. And to reduce the interference of to the speed, instead of printing out to the console directly, I prefer to redirect it to files, and then at the end we'll examine this file, and we'll run this code for how long are we going to run this code? Oh, at least 55 seconds. But let's just run it for 1 minute and a half, starting from now. So we'll stop at 2:18 p.m. What else? Let's be curious. In Java, maybe. Let's see. Boom. Oh, shit. In Java, probably the behavior would be a bit different because Java is multi-threaded. I don't know, or maybe it's just a little improvement to the timing. Yeah, maybe you'll get a more precise timing when you program in Java. So what companies are supporting this project? So well, you can imagine that Netflix use this type of programming a lot because their service is all about streaming. Even if you're not developing like Netflix types of solutions, let's say you analyze data for big data processing, probably reactive programming is still relevant or useful because you have a better control of the speeds at which you're analyzing or processing your data. I think we've reached one minute and a half, so let's just stop the execution and let's have a look at the file, the output.txt. Okay. Just by skimming through this file, I can say that we have achieved what we wanted to achieve. You see, let's confirm that this point is exactly, well, more or less 20 seconds since we start the application. It's 16:55, so this one should be 16. Yeah, so yeah, it's 24 seconds, 20 more or less, 20 seconds more or less. So what happens here, after 20 seconds, the tweet stream becomes slow, and so the retweet stream will start becomes more active. Instead of emitting every 3 seconds, you see here, initially it emits every 3 seconds, 33, 36, 39, 42, every 3 seconds. After 20 seconds, it will speed up to emitting every 1.5 seconds. One, you see, this is 1.5 seconds time difference. And then after 55, after 50, at the 55th seconds from the start, let's 55th second from 16, that would be 17:20 or 17:30. Yeah, this at this point, or at this point maybe 17:20. Yeah, so it's like 55 seconds. The tweet stream goes back to normal, so it emits requests again every 1.5 seconds. So the retweet stream will go back to its normal pace, which is emitting every 3 seconds, 29, 32, 35. Yeah, so I think we achieve the behavior that we wanted. So the next thing I would have to do is copying over this code and inserting it into my crawler code here. All right. So I think that's all. That's all. My video. I hope you. Yeah, I hope you start getting the idea of what reactive programming is. You got a glimpse. At least you know what libraries you can use. And so yeah, I invite you to get to know of this exciting